well can we do with these three genes? To answer that question, I used some simulation software provided by Pepe and colleagues to simulate a three-gene model under the parameters we derived from our own data. And this is the risk distribution for a population of 100,000 people. And what do we observe? Well, in the very low risk groups, as you might expect, we do pretty well because most of the people that are told they're low risk will in fact truly be low risk. In the highest risk group, which has a pretty rare, this is a rare combination of risk genotypes, only 391 out of 100,000 people are in this group, right? So to identify these really high-risk people, we'd have to screen 100,000 people to find those people. And obviously, since the risk is 50%, only 50% of this group is truly at high risk. This echoes this observation on a simulated with parameters that match our data, echoes the conclusion in Pepe's paper that to date, risk SNPs are unlikely to be helpful in identifying large groups of individuals at substantially elevated risk. It's a very small group in our example. And indeed, in this New England Journal paper that came out in March, where they looked at breast cancer with the 10 genetic variants, they echo the same point. We see little evidence of benefit from including genetic variants of the stream of low risk and high risk, categories in which future further stratification might be most valued. So you could say, well, we're only using 3 SNPs. How many SNPs should we use? We're not using enough. Well, so people have looked at this question, and Johnson said if you were using common variants with odds ratios of 1.25, how many would you need? On average, 80. Develop a model useful for identification of high-risk individuals, and their criteria for useful was an AUC greater than 80%. Although we've just seen that an AUC greater than 80%, I'm not sure how useful that is. David Clayton, in a very thoughtful and well-written commentary in PLOS Genetics, concluded that modest prediction power would still be the case even if all relevant rare and common variants were ultimately discovered, which is sobering. And why might that be? Well, one of the issues is as the number of factors goes up, as we saw in my simulated data example, you end up with small numbers of people in some of the categories. And if you measure enough of them, you're going to have each person likely to have a unique combination. And a very rare unique predictor may have limited usefulness. First, it's hard to determine causality when your sample sizes are very small, and it can also be quite costly to screen. It's important in this area to remember that most of these various studies are from case-controlled studies, and so the effect size estimates may be off, because they'll give you a bias. It's a biased sample, and there's this Weyer's curve where you overestimate the effect size in your discovery data sets. So I would argue that, and many people also argue that these risk SNPs, if they're going to be used to provide risk estimates, need to be evaluated in independent sample because of this overfitting issue in the model building data set. And that argues for long-term, large, longitudinal studies, some of which I believe NIH is starting to fund now. Shortly after we published our paper, Peter Kraft and colleagues came out with a review or commentary dealing with similar issues, and fortunately they also reached similar conclusions to us. So they said genome-wide association data are potentially subject to bias owing to the design artifact, which are the Weyer's curves, and whenever possible, the accuracy of the estimated absolute risk for the genetic profile should be verified in prospective studies. So I think what I've shown you so far is that highly associated SNPs might not be that effective as classifiers, even if you have first you need a high odds ratio, but even that doesn't guarantee that it's effective. Even if has a low p-value and has been widely replicated. And Peter Kraft and colleagues echoed that. Typically, measures of marker disease association do not directly assess clinical validity. impossible to appropriately evaluate the clinical utility of current or future genetic profiles based solely on measures such as population attributable risks and relative risks that were derived from case control studies. So we did pretty well. I mean, in our study, we had 3 strongly associated SNPs. 2 of these had relatively large odds ratios, and then we got up to an ANC of around 80%, and you can actually double the number of people in the true cases in the high-risk group using these SNPs. But I think, as I showed you, if you applied this to the general population, you could needlessly alarm a lot of people. Now, in 2009, late 2009, Mrs. Collins, who's now the director of NIH, sent off his genetic material under a pseudonym, because I guess he didn't want to be identified, to 3 of the leading personal genetic testing companies. And he found that, as the Nature paper of Craig Fender's group found, that the genotyping was accurate, but the interpretations substantially different. In his case, at least what he wrote in, what he told the news is that this resulted in what we want to see come out of these things. He discovered something. He discovered that it carries 2 copies of the most common risk factor of type 2 diabetes. It's kind of ironic because he spent a lot of his life contributing to ciphering the genetics of type 2 diabetes. And what did this do? This motivated him to make some positive lifestyle change. Upon learning the test results, Collins got off his Harley Davidson and instituted a regular exercise regime. And we're told he lost 20 pounds or more. Now, what was the better positive lifestyle change? The exercise or getting off the motorcycle? Now, that's the positive outcome that we'd like to see from providing these services. But I worry about the burden of unnecessary fear. And here's a recent example from late last year from Steve Hauser and colleagues. It was Christmas season in the Bay Area. A strapping and entirely healthy 27-year-old received from his parents a Christmas gift, personalized genomic testing. The results revealed that he was a carrier of genetic variants that increased the risk for ALS. The young man was frightened and the family devastated. So this was a great gift. So why does Steve Hauser know about it? Probably because this young person came to him. And so they looked at what these results were based on, divided by this direct consumer test. The analyses looked at a common variant in a single, not yet replicated, case control study. Not replicated. In that study, the variant increased the ALS risk by about 30%. And this test is less predictive of ALS risk than by simply determining if the individual is an athlete or a smoker. So this is the kind of outcome I really worry about. An interpretation was provided to the consumer, and it wasn't based on very good data. And indeed, in a recent review in Nature Review Genetics, Guttermaucher and colleagues said that the premature clinical integration of genomic information can result in a cascade effect, resulting in inappropriate follow-ups that are potentially harmful, as in the case of this young man, and that would constitute an unjustified use of healthcare resources. So if you create a whole bunch of unnecessary fear, all of a sudden you're creating a burden on the healthcare system. And now, that was a young man who perhaps, I don't know, perhaps didn't know much about genetics, but look what happened to Jim Watson, co-discoverer of the structure of DNA. He should understand genetic information. He didn't go to a direct-to-consumer company. He got his sequence. When he looked at his results, he found that he had a non-synonymous base pair change in his BRCA1 gene, and he felt that he had to tell his nieces about this. Right? So he's all worried. He was about to call them, and he said, "Wait a minute. However, before possibly needlessly worrying them, I called Mary Claire King in Seattle to look over my BRCA1 sequence. To my relief, she said I had a non-disease-causing Irish base pair change."